Let's go to the details about filter. We can use filter on top of iterable to return new iterable with all the elements satisfying the condition. It takes filter logic and iterable as arguments. We can pass filter logic either as regular function or lambda function. Filter returns a special iterable called as filter. We have to typecast to regular collections such as list to preview the data, or we can use for loop to iterate and print the data. Number of elements in the filter object is typically less than number of elements in the original iterable passed to it. Because we are going to filter out those records which doesn't satisfy the criteria, the number of elements as part of the filter object will be typically less than the number of elements in our original dataset. Now let me run this to actually create orders and order items by reading data from the files into the lists. Orders is of type list and also order items is of type list. We can preview the data in both orders as well as order items, and also we can run len function on top of them to see the number of records. To get the help on filter, we can say filter ? like this if we are using Jupyter environment. If you are using Python CLI, you can say help of filter and you should be able to see the help on filter. You can see that filter takes function as first argument and iterable as second argument. If the function is not passed, then it will actually return the items that are true. So if you have a collection with the trues and falses, it will just return those elements which are true if you do not have function. But typically we will have a function when we use filter. That being said, we need to pass a function with filter logic and an iterable to filter. Orders is iterable, and hence we can use that as the second argument to filter. So let me preview the data for orders. We can see the first 10 records here. And if you want to compare against a particular customer ID, this is the customer ID. We want to extract the customer ID by saying order.split using comma as delimiter. It will return a collection, and we can fetch the customer ID by saying of2 like this. However, customer ID is of type string, but the original type is integer. It is a good practice to typecast to integer and then compare. So this will actually take care of extracting the order customer ID as integer and compare with 11,599 here, which is nothing but our business logic to get those orders which are placed by a particular customer. Now using this simple code snippet, I can actually build the first argument by using lambda like this. So I can say lambda, and order is nothing but each element in our orders. So this will be invoked depending upon the number of records in the orders, which is nothing but 68,883. And for each record, it will actually split the record like this, then extract the customer ID, typecast to integer, and then compare with 12,431. So whatever logic implemented here will be executed against each and every element in our orders. And finally, customer underscore orders will only contain those orders placed by customer 12,431. You can check the type of the customer orders here. It is nothing but of type filter. If you try to access the elements directly, it will not show any elements. You can actually say customer underscore orders and then run. It will just show the type of this object, which is nothing but filter. To typecast and see the details in that filter object, which is nothing but iterable, you should be able to use list, and you should be able to convert the elements into the list object, and then you should be able to preview the results. This is how you should be able to apply filter and preview the data. If you want further processing, you can pass it for further processing directly without previewing using list function like this. Now let's take care of this task where we want to get orders placed by customer ID 12,431 in the month of 2014 January. We can run this. In this case, on top of comparing against 12,431, we are also extracting the date. This will actually give us the date, which is nothing but this part. We are checking if it is starting with 2014-01, which will actually compare against 2014 January. And then we are passing orders itself as second argument to this filter. Now you should be able to run this, and customer orders per month will have only those orders placed by customer 12,431 in the month of 2014 January. You should be able to use for loop also like this, iterate through the filter object, and you should be able to print the results. Either you can say list of customer orders per month to see the details, or you can also use the conventional for loop to actually print the results from the filter object. Now we just want to get those orders which are either pending or processing, or pending payment or processing for customer ID 12,431 for month of 2014 January. You just have to apply the logic like this. In this case, we are extracting the status and we are comparing the status against pending payment or processing. And this is how the logic will be. You just have to pass the orders, which is nothing but a list, which is nothing but iterable as second argument. For each and every order, this logic will be implemented, and you should be able to get only those orders which are placed by customer ID 12,431 in the month of 2014 January, which are either in pending payment or processing status. Now, you can also have a named function like this. So instead of just specifying lambda function for complex logic like this, you can have a named function. This named function takes order details, customer ID, order month, and order statuses. And this is how the condition will look like. If all the conditions satisfy, we are returning the order. Otherwise, we are not returning anything. Actually, we can return true here. We don't even have to return the order. If all these conditions satisfy, we just have to return true. And then wherever it is true, it will just return those objects. Now I can run this. In place of lambda function, where I have implemented the logic directly, I am invoking this check order function. It takes order details as first argument. To get the order details, I am just splitting the order by comma, and whatever list that is returned is used as first argument for check order. And then we are processing the individual elements by saying int of order details of 2 to get the customer ID, order details of 1 to get the date, order details of 3 to get the status. Rest of the logic is same as what we have seen earlier, but in this case we have implemented using named function, and this named function is invoked from the lambda function by passing the order details, customer ID, month, and the statuses which we are interested in. You should be able to run this on top of orders, and you can actually see the output. So you can either use a named function like this or pass the logic directly as part of the lambda function. So make sure you are comfortable implementing business logics as I have demonstrated here with more and more examples, so that you can leverage the filter or any other MapReduce related functions in the pursuit of processing the collections. You should be very comfortable with these APIs.